Hello, today we're going to learn how to build a Helio-STELLA and program it. We're going to start out, we need our chips here. So we need a button, we need our screen, we have our power switch, we have our real-time clock and battery. And we have our spectral sensor and our UV sensor, our microprocessor, and battery. Then we have our ping pong ball. Alright, so on our spectral sensor, we have a little jumper that we need to sever. We need to sever that so that the LED doesn't flash. We don't want to pick any of the green light from the LED up. So we're going to take that and sever that piece. You'll see up in the upper left-hand corner. That's exactly where we need to sever. Be very careful doing so. And once it's severed, the green LED light will no longer come on the power switch. I go over it a few times, I strike through it a few times just to be sure, and then I might look at it under a magnifying glass. Okay, and let's see, once we have all the pieces, let's start assembling. So remember with your quick connect that you want to do the shiny side down towards the PCB board and the side without any of the shiny wires facing up. Alright, and we slowly connect our sensors. Make sure you put in the battery into the real-time clock, positive side up. Okay, and then slide your quick connect on. And remember to brace the quick connectors. Yep, there you go, make it nice and snug. Alright, and we'll daisy chain these on together. Here we go. And this is our spectral sensor. We're going to put that on there and pop it in there nice and snug. And then up on deck will be our UV sensor. Okay, so we just daisy chain these together. Again, make sure the quick connects are nice and snug. Brace the back and push right in. You don't want to push too hard. I have broken one of these off before. Not a fun thing. Alright, and again, push into the sensor, the UV sensor there. It's UVA. Okay, and finally we'll connect the screen coming up here. Make sure it's nice and snug. There we go. Okay. There we go. And now let's test it. Let's go ahead and turn the power on and see if all the LEDs light up. Only one LED should not light up, and that would be the spectral sensor. See, note that the LED doesn't light up. Very good. Yep, because we severed the that jumper in the back, so it's well severed. And the UV sensor is on, and so is our screen. So everything is getting powered. Now we need to program. Alright, now we're going to program our Helio-STELLA. First, you will want to use a USB-C data cable, and you will want to hold down the boot button on your microprocessor. Once you do, you'll see RPI, RP2 show up, and you'll drag and drop your UF2 file into that disk. Okay, and then once it does, we should, after it loads for a minute or two, we should see CircuitPy mount. RP1-RP2 will dismount, and CircuitPy will mount. And once that does, we'll go up to our code and libraries in just a minute. There we go. Oh, let's see. That's what it looks like on the inside. Code and libraries. It will grab the code and LIB, folder LIB, and we will drag that and drop that into CircuitPy. Okay, and we want to replace everything in there. Give it another minute or two to load up. And even though this is going slow, this is sped up by about like 700%. For some reason, it likes to take a while for these things to upload. Alright, once it does, we'll load up our code in Mu Editor. So we'll go to our CircuitPy and load up the code that was just dragged and dropped in there. Click Serial, and now we can see the code as it's being run in that little display. Okay, and what we're just checking for is to make sure that everything seems to be up and running, and everything does at the moment. We're getting some numbers in, so looks like everything's pretty much okay at the moment. Alright, but we need to set our date and time. So our date and time is not set, so we will go to clock set in the Helio-STELLA test codes, drag and drop it, replace. Okay, and once it comes in, I like to reload the code so I can see if there's any errors and all that, and then we check out our time.is/UTC, and we set the time in UTC. And I go back and forth a few times with time UTC, making sure that I have the right day. Alright, and so we enter it in serial down there. We will enter the year first, then we'll enter the month. Okay, and then we'll enter the day and the time, all of that. And eventually we need to enter in the actual day, you know, Friday, Saturday, Sunday, whatever. I do like to the save time seems to have about a 5-second or so latency, so I do like to go about 5 seconds ahead when I enter the time in. That way it hopefully makes up for any latency for save files. And it seems to work out pretty well. Once you have all that, you can close the window. Oh, and then you can go back up to your code.py and under code and libraries and drag and drop that back in there. Okay, but your time is now set, and now all of the measurements that come in from your sensors should have relatively accurate time. There is some drift in the RTC, so it's probably best to sync it up, you know, every month or so. Alright, and I always like to go back in and check my code to make sure everything's running. Looks pretty good. And there you have it. We have a programmed Helio-STELLA. Note that there is no SD card in there. That's why I'm saying that the SD card failed. Now, we're going to put the Stella into the optional 3D print mold. And this is a fantastic mold created by Paul Mirel. Okay, and I'm about to cut a ping pong ball in half. Be careful when you cut this ping pong ball. Alright, practice good safety, you know, wear eye protection, so on and so forth, and cut well. Leave a little bit of tab. I left a little bit too much on there, and you'll see that a little later when I have to clip a bit of it off. But it will go right over your spectral sensor. As long as you have at least half of the ping pong ball, you can always clip it down a bit. Now, when I'm putting the parts into the Helio-STELLA body, I like to make sure everything is relatively flush. I do tuck those 2 wires back in there. I've noticed that seems to work pretty well. And I start to lay things out a bit. I don't always put the holsters in for each one, but some of these I like to wiggle around a lot, especially the button and the microprocessor. Alright, now we have to take off a few of the supports that are on a 3D model. So this is a little support on the sides. Make sure it's clean and clear, because the backing won't stay on there if you don't. Now there's a little piece down there to keep the another 3D printed piece in place, and so you be a bit gentle when you're doing sort of pushing on those mounts inside of the 3D housing. Okay. Yep. And I might clean that up. Say, yeah, there we go. Clip that down a little bit to make sure that the mount works as it's supposed to. Usually these supports come out pretty easily. It's not too big of a deal, and you clean up the area. So, and then the backing itself also has little supports on it as well that need to come out. So once you pull them out, it should look like a nice rectangle, and you'll notice that when you go to mount it, if it sits flush or not. Just make sure that it's cleaned up pretty well. All right. Let's continue putting stuff back in here. Okay. And I do like to make it a little bit nice and neat. I can guarantee that Paul's is a lot neater than mine is. So, and also if you take a look, you can put things in slightly different, in a slightly different way. It's best to check. And again, you had a few little lessons learned in there with this, but yeah. Okay, half a ping pong ball. Obviously, I left too much of a tab by quite a bit, so I'm going to need to trim that down. And there's the brace that holds that ping pong ball in there. I wish I had recorded the ping pong ball conversation that some of the engineers had. It was quite brilliant. And a lot of fun coming up with a diffuser and how we're going to use it and how we might try to do some calibration. So I trim that down, see if we can pop it back in. And again, a little bit of trial and error, never hurt anyone. And so I do suggest having, at least 2 or 3 ping pong balls as you do this, just in case, because it does take a bit of trial and error. And once you have it on, attach your brace, make sure it's looking good, make sure there are no holes in the top, and you can put your spectral sensor on. Put the spectral sensor right into the brace, and because Paul is fantastic, just a wonderful, wonderful man and wonderful engineer. He makes a nice little brace for the spectral sensor. Now I like to put in the display before I put in the other stuff, mostly because some of the wires can start to interfere with the display a little bit, and so then we put that all in there. Okay. And pop that in, and battery, put that all in there. Now the wires are all loose, so now you have to clean up the wires. And this is kind of a fun part because you can try and think of a multitude of different ways of wrapping it around the various posts and stanchions that Paul has put into this awesome case, and try to make it look nice and neat. Try not to force the wires, try not to too much, and be a bit gentle, because they still are wires, so don't pull on them too much. Just wrap them around nice and neat. I'm a bit ham-fisted, as you can see, so I got short sausage fingers, so it's a good time popping this stuff in. And again, we've accelerated this video just a bit, so you don't have to sit there and watch me for 5 minutes fiddle around with one wire. But yeah, wrap around, make it nice and straight and all that. Basically, you just don't want them rattling around in there. Okay, especially for your Q2. This is the Helio-STELLA, but the Q2 is an actual drone case, so you can pop it up on a drone. This one's just a gorgeous case for the Heliophysics Stella. Alright, once you all have it tucked in and all that, looks good, put the backing on there, snap it closed, and it's time to test. Alright, so we're turning it on, it's going through its boot process. Okay, it's going to give you the date and time. Alright, this one actually has the optional BME in there, so it's going to show some barometric pressure at a certain point when I click through. But you should see the nice little spectral graph come up. Okay, you can push down the green button and hold it down, and you'll have a nice reference light. hold it down again, you'll turn the reference light off. Okay, if you do a quick touch of it, it will start cycling through the various spectra that it's taking. Let's see, here we go. So for this one, like I said, there's a BME in there, so it's getting some temperature and weather data. You got the lux and then the UV, okay, coming in, and then we're going to go through the spectral signatures that are on the spectral sensor. All right. So I hope you have a great time building your own Stella, and thanks. Come again.